Good morning. Well, my morning. Good day to you all. Hello and welcome to the Spring One Tour, June edition. Almost to July. We're at the very end of June here, and we want to thank you so much all for joining us. We have an exciting day today and tomorrow. We have a lot of information to pass on to you, and so I don't want to take too much time at the top, but I do need to let you all know some kind of fun informational stuff as well as our agenda. So today we're going to have our presenters uh, giving you so much great information, and then tomorrow all that information that you've gathered we're going to have in a fireside chat. So you might see on the bottom there a Q&A button. You can ask questions. We have a couple of people monitoring that Q&A space, and if they can answer anything they will, and then if there's any questions that we can pass on to our presenters, we will do that either at the end of this session or we'll add them to the fireside questions tomorrow. And so excuse me one second. Let's get on to who these presenters are, shall we? We're going to do the CI/CD experience, which is the Kubernetes edition. Everybody's talking about Kubernetes, and so we're really excited to share with you Cora Iberkleid and Andreas Evers' take on Kubernetes and the CI/CD experience, which Cora, if you don't know, she is a member of the VMware advocacy team right now. We have her on loan. We extended her another 3 months, which we're so excited about. But she's an advisory cloud application and platform architect at VMware. And she's been with VMware / Pivotal beforehand for quite a long time. And she is an amazing platform architect is what we call them. And then Andreas Evers, he's been a senior solutions architect on the application transformation team. He is actually coming to us all the way from Belgium. So we're excited to have, and Cora's in New York, so we're all over the globe right now, bringing you this incredible information. One of these nice things about the Zoom era that we're in, I'll call it the Zoom era, and we can actually bring all these people, and you included, wherever you all are, to listen to this information. And we're all still in the comfort of our own home. I've got my dogs at my feet, and my children and wife are in the other room making breakfast. So it's all exciting that we can still do this and share in this community that we've developed. So thank you so much. If you joined us for the last Spring One tour in May with Nate Schuda and Jakob Pillemon, we're going to have great information like we did over 2 days this time around. So we're very excited. And I'm just trying to make sure I have all the things that I've needed to say before we get on to everybody. Yeah, that's it. Make sure that you put in your questions and answer. Well, we have the answers. You have the questions in the Q&A, and we're gonna introduce Cora and Andreas. So Cora, Andreas, welcome to Spring One Tour.
Hello. Good morning. Good afternoon.
There it is. Hey.
How are you? We're very happy to be here, and we're excited to get started.
Yeah, I think we should just get off and running. We have lots of great participants ready to go. They've got their participants on, I'm hoping, and not their PJ pants. And
right.
And I'm going to sign off, and we'll see you all in a little bit. We're going to take a break. There it is. Yes, we got the left track. Thank you, Paul. Paul is on the ones and twos, helping us with our AV stuff along with Brandon. So thank you, everybody on the team. And yes, let's get it going. Without further ado, everyone, Andreas and Cora.
Great. So I have to share my screen here. So let me just make sure everything is ready to go. Sorry about this. We have a lot of demos, and of course, we are hoping everything goes well. So just everybody keep your fingers crossed for us. And okay, so I'm going to share my screen and kick us off. All right. So is that the right screen? This age, it's certainly a challenge to get used to giving presentations on Zoom. We love this coordinated fashion, but bear with us. Okay. Does everything look good on screen? All right.
Yes,
so today we're going to be
I
talking.
should have
Okay,
answered
thank you,
that
Bob.
quicker, so
I
yes.
appreciate that confirmation. So Andreas and I are going to be talking about the CI/CD experience for continuous integration, continuous, deployment, delivery. There's all these acronyms. So just to introduce myself, as Bob said, I'm a developer advocate. I've been at VMware for 6 months since they purchased Pivotal, at which I worked for 5.5 years. And Andreas?
Hi, yeah, I'm Andreas Evers, Senior Solution Architect at VMware as well, coming from Pivotal. And I'm focusing on application modernization. Pretty cool stuff.
Awesome. So this is just the abstract that you're all familiar with from signing up for the webinar. And just to recap that, the context for this is that Kubernetes is making everything inherently easier to automate. CI/CD is traditionally a very difficult thing to do. And different companies are at different stages in the maturity of their processes. And Kubernetes is really giving us an opportunity to reevaluate and do things in a simpler way. And also there's an emerging ecosystem around this. There's a crossover of patterns that have been honed in the development landscape and the infrastructure. And so now developers are adopting infrastructure practices and vice versa. So it's really exciting. And we're gonna build out a demo for you using a selection of tools. So we'll do this over the course of day 1, which is the next 2 hours. We're gonna cover building images, managing your configuration. We'll talk about GitOps and continuous operations as a continuation of CI/CD, this new CO term. Automating your image management, automating your workflow, and things around chat ops that are much more on the development workflow. Some integrated solutions, opinionated pipelines, all of these different things. We have a lot to cover, and we have some homework for you guys that you can do it at your own pace. But if you do it within the next day, then come back tomorrow. Either way, come back tomorrow. But you can come back tomorrow and participate in this fireside chat with us. We'll have some folks who have a lot of experience in this area. Lyle Murphy, Mark Fisher, Mark Pollack, Paul Zarkowski, that work on the Spring team in the CI/CD space. Paul is our very own developer advocate, very well versed in all things Kubernetes and DevOps. So we're excited for that tomorrow. Yay! Perfect. So with that, I'm going to hand it over to Andreas for an introduction. And Andreas, I'm actually going to suggest that you share your screen.
All right.
If that's okay. All right, cool. Thanks.
I gotta stop sharing though.
Oh, right. Sorry. Little things to remember. Got it.
All right. There we go. Cool. So, introduction. Cool. So when we talk about CI/CD, what we actually talk about is how to get our code into production. So path to production is very important to us, of course. I've seen teams that just take their code and FTP it into production. That's one way. Of course, there's no golden path here. There's no golden path to production, but there's definitely a couple of things that you might want to think about when you go to production and when you build out the CI/CD pipeline. So, of course, the first thing to think about if you do this with FTP is how can we automate this stuff? So deploying to production itself, of course, is something to work on. But then also from the code perspective, how do we make sure that it's tested, it's validated, then also how to package this up. We're going to spend some time on that as well today, so that's going to be interesting. Then take that package and deploy that onto a test environment, do some validation there, and eventually promote that into production. So that's a pretty common pipeline. And then you can have some stuff on the left as well to focus on collaboration. So aside from, of course, just talking to each other, you can have pull requests as well with feature branches, reviews on those pull requests. We're going to look at some solutions there as well. And on the right side, production itself, when you roll out, you can do that in a strategic way. So you can have strategic deployments and strategic rollbacks. And of course, when you're on production, you should also not forget to test that and monitor it to to make sure that it stays running. So when I talk about the packaging part, there is, of course, the application to package up. But nowadays, we also can look at the declared states of how we actually want to run this in production or on a certain environment. So packaging together the application with the declared state of what you wish to have on an environment, how you wish to run this, is an interesting approach, which allows you on production on the right side to maintain your application in an easier way. So this entire pipeline, as you can see it here, is basically there to increase confidence that whatever you have built is going to work on production and that is going to be deployed and kept on production in a sane way. So that's basically the path to production that we're going to talk about today. Of course, there's a lot of elements to it, and we're going to have demos as well, filling in some of these building blocks. Should I switch over again? I'll just switch. Cool.
Okay, can you hear me? Oh, sorry. Yeah. Can you hear me now?
Yes.
All right. Okay, so we're at the demo preview. All right. So, okay, so now that we understand the basic flow, we want to overlay on that exactly what we're going to be showing you. So, of course, most basic, we're going to be deploying onto Kubernetes, right? And the great thing about Kubernetes is that it introduces this system that is based on this idea of infrastructure as code. The Kubernetes API itself, there's a lot of tools that describe themselves as being Kubernetes native, and really what that means is that they're extending the Kubernetes API, and so the Kubernetes API is composed of these resources, and we can interact with them by way of declaring the data that gets sent over to them is JSON, but we declare YAML structured files, and so when a tool says that it's Kubernetes native, it's basically providing us new resources, and we can use YAML to interact with them. So that gives us, and then Kubernetes with that YAML takes care of making true what we've asked for it, right? So this system is kind of changing the way we can do everything else, which is cool. So that's the foundation, right? We're also going to be using Git as a system of record. Git has proven to be extremely valuable on the development side of the house in terms of storing, versioning code, security, being able to roll back to a previous commit. And there's this extra, pull request merge feature functionality around it. So it lends itself very well to be used now for the declarative YAML files that describe what we want running in production. So it's this beautiful sort of synergy between both sides, infrastructure as code and Git versioning. So that's the foundation of GitOps, but there's more to GitOps than just that, and we'll see how you need additional tools besides Git and Kubernetes to really have a fully defined GitOps thing. So one of the tools that we're going to be using is Argo. Argo is the tool that we're going to use to deploy things to Kubernetes, essentially, whatever those things are, and really wherever in the process they are. We're also going to be using a pipelining tool to bridge the gap in those workflows where we need to do something more customized. Tekton has the building blocks that we need to put these sort of pipelines together. And finally, we're going to introduce a tool called KPack, which is it's within the ecosystem of a cloud native build packs, which we'll also introduce to do some autonomous, automated building and maintaining of our images, which are the things that we deploy to Kubernetes. So that's tool-wise what we have planned to put together for you. And our baseline starting point is having a source code repository. You might have a Docker file in order to turn that source code into an image that you deploy to Kubernetes, and some manifest to describe to Kubernetes exactly what you're deploying. So having said that, the first topic that we're going to talk about is the image as the new artifact. So let's put some context around that. So this flow, if you think about this flow, for example, in the context of Java, this might mean that you take an application and you build a jar file or a WAR file out of it, and then you deploy that to a virtual machine. that's been prepared for your application, right? This is pre-Kubernetes, sort of the traditional workflow. That preparation would involve a guest operating system in the virtual machine, maybe some runtime, like for example, the JRE is usually pre-installed. Maybe an app server is pre-installed if you're deploying a WAR file. Some shared libraries might be pre-installed by an ops team. And the application, the jar file or the WAR file is the artifact, is what we consider the artifact, right? That if you have Artifactory, if you have Nexus, that's the artifact that you hand over from CI to CD. Now with Kubernetes, that paradigm changes, and the platform itself no longer comes prepared with all of those dependencies, but rather it becomes the responsibility of the packaging stage of this process to make sure that all of those components are included with the artifact. So you can't just throw your jar file into Kubernetes, right? You have to put your jar file with with even a container operating system, with the JRE, with all of your files, and that's what you deploy to Kubernetes. So why would we shift all this responsibility left, right? I think generally we try to make life easier for developers because we want to have developers be able to focus on code that might add business value. So why are we shifting this stuff left? And the reason for that is that we want to be able to deploy and run software in a repeatable and reliable way across computers. And the way to do that is precisely to package all of those dependencies with the application and to standardize the runtime environment, standardize that packaging format. And then from an operations perspective, it's much cleaner to be able to provide stability and reliability in a consistent way. So the first task in terms of taking an application and deploying it on Kubernetes is to figure out how you're going to build that image. So and then deploying that, right? Because that's what containers are at the end of the day. They're running instances of our images. So having said that, let me switch over to here. So we'll do this by way of a little demo. Now, throughout this presentation, we're going to be using a very simple Go application. It's just a simple hello server.go file. If you run it, just send the stuff to the background. It's listening on port 8080 and it just answers hello world, right? That's it. So let's talk about how you might build this. Now, the de facto way to build images is Dockerfile. Dockerfile has been around for as long as Docker has been, and it's essentially you're writing a script. So you decide exactly how you want to build the image. And here's an example of a Docker file. So you can see that the words in capital letters on the left are the standard Docker instructions. So every line has to begin with a standard Docker instruction. They don't have to be capitalized. It by convention is easier to read it that way. But it's composed of blocks. You may only have one block, but you can see here's an example of what we call a multi-stage Docker file that has 2 blocks of statements, each starting with a from statement. The from statement gives you an environment in which to carry out a certain set of instructions. So normally if you're deploying an application, you first build it and then you release it. And so this is what this is reflecting, these 2 stages. The first one is a build stage, and the second one is producing the image that you actually want to put in your runtime environment. Because you don't want to put in things that you don't need into your runtime environment, right? For example, you need a JDK to build, but you only need a JRE to run. So you wouldn't put the JDK into your runtime image. So this is why this multi-stage approach allows you to separate these 2 environments. So the from statement provides you that the container, the image in which you can do that build. This is just pulling down a publicly available image from Docker Hub that has the Go tooling so that I can do my Go build. And you can see that in this Docker file, there's been several decisions taken by the Docker file author in order to make this a decent Docker file, right? So one example is copying the module files before copying the actual source code, and downloading the modules before building the application. And the reasons for this have to do with leveraging the caching that is built into the Docker build. If you wait later in the file to copy files that change more often, then you'll be more you're more capable of using caching earlier in the process. So it's more efficient that way. And here we're also setting the command that we want to run. So when somebody runs this image, it'll start up this command and it'll answer hello world. Not all decisions are perfect in here. There's no version, for example, on this tag. So if somebody builds this image maybe a month from now, maybe there was a new Golang release, and so that person would actually be starting with a different version of the Golang environment, maybe a different Go compiler, which is won't necessarily, doesn't always have negative consequences, but generally when you're building things for production, you want to make sure that all of your builds are exactly repeatable. All that to say that it's the responsibility of every Dockerfile author to get this right. And you have to get it right in terms of your choice of images. Do you trust them? The instructions? And then how do you share this across your organization? There's no built-in mechanism with Docker files to share these things, or for operations to have insight into what went into a Docker file. So while Dockerfile is the de facto way, and there's a lot of Docker files out there, over time, there have been improvements in the ecosystem and higher level tools that try to solve the problems that Dockerfile presents. And so I want to introduce one of those today, which is build packs. Now, with build packs, there's basically three parts of that you work with. There's the actual tool that you choose. So in the case of Dockerfile, in order to execute a Dockerfile, you would run docker build and then your Dockerfile, right, and give it a name. And that build would happen on the Docker daemon. So you're using the Docker CLI. So in the case of build packs, you have a choice of tools. There's a CLI called Pack, which I'll demo in a minute. But because this is built on APIs, there's actually an ecosystem growing around this. But Pack would be sort of the CLI equivalent of Docker. There's also build packs. The build packs, and they're generally packaged into an image called the builder. That builder image will include the image that you use for your build environment and the image that you use for your run environment. And they'll include modules that contain all of the logic that you would otherwise code into your Docker file. So those are the build packs are the actual logic, and the builder image includes the build packs plus the base images. And the last part is this lifecycle, which is this piece that the project behind build packs provides this implementation of the actual orchestration logic. So if you think about the Docker build actually happening on the Docker daemon is actually executing the Docker file and taking care of the orchestration, leveraging cache, etc. The lifecycle is playing that role. And the lifecycle is also installed into the builder image, so it's pretty easy to access all of it. So that's how it sort of relates. So in order to use this, of course, I need a builder, right? I need my builder that will include my build packs, my lifecycle. It serves as the image for the build, and it contains a reference to the image for the runtime. So I don't want to type this long string all the time, so I'm just going to set it as my default builder. And as I mentioned, it's an ecosystem, right? So any organization, any project who writes software that complies with the build pack API specified by this build packs project will be a valid build packs implementation. So Paketo is one such implementation. It's actually the evolution of what used to be of what's known as Cloud Foundry build packs. So this is a cloud native version of those. So I'm going to use a command called pack. Again, pack is now a tool that implements the other API in this project, or one of the other APIs in this project, which is the platform API. And the tool just has to orchestrate this lifecycle in order to use the build packs. So that's what pack is doing. So we have a pack build command, very similar to Docker build. We're giving our image a name. And I'm just going to say no pull because it's a little faster that way. I already pre-downloaded the builder and the run image. So what you can see in this log file is the process that Pack is orchestrating the lifecycle, right? So here's the lifecycle. First, it does a detection. It goes through all of the build packs that are in the builder, and it says which ones apply to this application. It figures out that it's a Go application. Analyzing and restore have to do with leveraging cache. As the image, it uses both information about the layers that have been previously built, as well as a separate cache. So it's really quite efficient. It's a pretty sophisticated caching system. Then it actually applies each of the build packs that it determined was applicable. It applies them in order. And so that's processing your application. And finally, it exports all of those things into the run image, right? So this is the equivalent of the second build stage that we saw in the Docker file, where we had the copy of the binary into the slimmer run image. That's the export, and then of course it populates the cache. So at the end of this, we have an image. And so this is our application image. And these are just the builder, the lifecycle, and the run image, right, that are used in the process. You can see that it says that it's 40 years old. And the reason for that is that timestamps have to be set to a uniform time in order to guarantee that if this image is, if the same code is processed by the same build packs and the same base image, and you know, you have some configuration you can do through environment variables or through a YAML file. If all of the inputs are the same, then if you build this at a different time, different machine, you'll get the same image ID. And so for that, of course, timestamps all have to be kind of set to the same number, so we lose the created time. But that's, so it's pretty powerful, and it has also, it offers a lot of transparency. So you can see already that, like, because these build packs are there, the Paketo build packs are available on Google Cloud. Of course, if you're an enterprise, you can place build packs on your private registry. But either way, all of the enterprise developers or all developers in the world can have access to the same set of the same builder image, and therefore it gives you this mechanism which is lacking in Dockerfile to share best practices that are prepackaged into modules, essentially, right? So that's also a very powerful aspect. And it also gives you some inspection capabilities. So there's 3 different inspections that you can do at the through Cloud Native build packs. And sorry, this is just a tiny bit slow. So this inspection gives you information from at the lifecycle level. So it's really just saying, like, which build packs were they, what versions, what's the start command, things like that. If I added a --BOM, which stands for bill of materials flag, I would get information added by each individual build pack. And interestingly, if you're using a Java application, the Java build packs add every single Java dependency. So that's quite good to know. There's also an inspection on the builder itself. So you can see that with this builder that I've set as my default, I could actually build Java applications, Node applications, Go, etc. I have links to the home pages of each of these. So if I want to learn more, they're all open source. The reference to the run image is here. So you get a lot more transparency as well. Also an advantage over Dockerfile. And then it's got other features. I'm not covering all the features. I just want to highlight some that are most relevant for this particular talk. But there's a function called rebasing, which patches just the OS layer. So if you're using a Docker file and you want to change the base image, you have to change the from statement, which basically invalidates, it means you have to rebuild your image, first of all, which there's always risk, right, in rebuilding something you didn't really need to rebuild. Plus it invalidates all of the caching before that. And you have to repush your image up to the registry. In this case, it takes advantage of OCI image structures, have a manifest file that point to layers, and V2 registries. Those 2 things together give you some additional capabilities. So what I'm going to simulate here is, let's say that something like Heartbleed or Spectre happened, and there was a vulnerability found in the operating system, and it's affecting all of our images. Let's say you have thousands of images on your registry, right? So a patch is made available in the form of a new run image, right? So I'm getting that patch. Basically, I'm getting a run image with patched OS. And the builder is, if I rebuild this, then the builder would be looking for an image with this alias, this tag. So I'm simply going to use that alias and point it to this new run image that I just downloaded. And so now that that's tagged, you'll see that I downloaded 0019, which is this image SHA, and that same SHA now has this tag that is the one that the builder is looking for. So now, if I would rebuild, it would use the new one, but I don't want to rebuild, I want to rebase. So I'm just going to go ahead and do a rebase. And it takes a few seconds on local machine, it's milliseconds on a registry. But essentially, so my app image had an ID of FFOB, and now it's created a new image with a SHA, but all it's done is pointed the manifest to a couple of new layers in the base of image. And I can use Docker inspect will list the SHAs of all of the layers in the root FS, right? So you can see there's the root FS section of the Docker inspect comparing the old and the new, and you can see that 2 of the layers have changed. And that was really quick, right? So the last thing I want to show you is publishing. If you were using Docker, you do a Docker build, make sure to give your image a name that has enough information to say what register you're trying to publish to, and you would do a Docker push. Of course, you can do that with any image generated by build packs, but there's also this -- publish command that's included right with pack build. So I'm just giving a namespace here that corresponds to a particular Oregon Docker hub, and good practice is to provide some tag for your image. And so this is going to send the image up to Docker Hub, and that might take a few seconds. See if it finishes fast enough. Since I'm giving it a new name, it's actually not reusing the old cache. It's creating a new one. So let's say we'll come back and check on that. While it's doing that, let me go to the slides. So just to recap, right? So there's also the life cycle, but from a user perspective, really, you're dealing with platforms. So we've just chosen Pack as our platform, as the tool that we're going to use in order to take advantage of build packs. And from a build packs perspective, we chose Paketo build packs to provide us all the components that we need. And the Paketo build packs are split up into little modules. You can always introduce a custom one or an additional one before or after the ones from the builder. It's quite flexible and very easy to use. And the history behind this, as I mentioned, is it comes from the history of build packs. That Heroku initiated build packs around 2011. Pivotal Cloud Foundry adopted them very much, and Pivotal is the company behind Cloud Foundry, now VMware. But both of these companies together founded this project, and they basically took a lot of the lessons learned from the first generation of build packs and designed a better system. So they inherited the code bases with all of the honed build packs from the last 10 or so years, and they built API-based foundation for based on the latest Kubernetes standards, latest container standards, to foster this ecosystem. And there's some really cool features kind of built into that. So that brings us to the deployment part. And so before I do that, let me just double check that this finished and that we're setting up. So we're publishing images to this particular Docker Hub repository. And is there?
Yep, looks good.
Go demo app, sorry, yeah. Go demo app. And there we go with our pack 100 tag. So at this point, we're ready to deploy that to Kubernetes. So I'm going to hand over control to Andreas to walk us through that.
All right, let me share my screen as well. There we go. So back on the slides. As you can see, we have our code change, of course, or our code in general in our app repository. And we've been talking about how we can build this image and push it to Docker Hub in a new way with build packs. But now that it's in there, now that we have the image, we'd also like to deploy this towards Kubernetes, of course. So that's the next step. So let me just jump in that with a little demo. This is just straightforward, I suppose, for everyone. But let's create a deployment and let's create a service. So I'm going to use that tag that was just pushed, and I'm going to create that deployment. So I'm mentioning the image. Go up. There we go. And the specific tag that was used, I think it was pack 100, if I'm not mistaken. This is an imperative command, which means it's going to create the resource without actually being declarative, without having the YAML. So, but I don't want to do this. I just want to use this command to create the YAML for me. If you've ever done the CKAD exam, so the Certified Kubernetes Developer exam, then you probably know about using these imperative commands, how easy it is to get YAMLs created. So that's what I'm going to use it for. So I'm going to dry run on the client side, and I'm going to put some YAML into deployment YAML. Right, this was looking good. Oh yeah, let's make sure it's also in the dev namespace, because I want to have one for dev and one for prod. Okay, cool. All right, and let's also do the same for a service. So let's add a service here. So I want to create service of type cluster IP. Right, can have the same name. Of course, it hasn't got an image, but it has a port that I can open up. So TCP port, and I think the application was exposed on 8080, right? Right, good. Also for dev, and we're gonna name that something else, of course. Service.yaml. Okay, so let's make a tree here. Oh, whoops, I'm in the wrong folder, but that's okay. ls, there we go. So we have deployment YAML and service YAML. Let's just take a look at it. I'm using YQ to visualize my YAMLs. It has this coloring feature, so that's pretty useful. If you're not familiar with YQ, it's like JQ, but for YAML, and it also has the ability to modify your code, which is also pretty nice. Okay, so deployment YAML looks like this. Well, that's all right. That's looking good. And the service looks like this. So this is Kubernetes 101, I suppose. Fairly simple. All right, we can apply this stuff. So apply deployment YAML and the service YAML as well. Right, I'm in the right namespace. Yes, in dev. Okay, great. So this should be running now on dev cluster. So that means the dev namespace on our cluster. So yeah, it's running. That's cool. That's service. Yes. So now let's do the same for production, because I'd like to have also exactly the same thing on production with the different namespace. So I'm going to run this here to the command again. So this deployment here, and I'm going to change the namespace and the name of the YAML. So this is also very straightforward. There we go. And then the service as well. So let's change here the namespace to prod. Zoom a bit around. There we go. Okay. So I can also apply this. So this sets us up for the next part of the demo, of course. So deployment for prod and deployment and service for prod as well. Okay. Oh, whoops. On the right namespace. I think that's okay. So let's prod. Let's see, get deploy. There it is. Okay, great. So we got our stuff set up. Thank you. This is very challenging for me, but let's take a look at what I've just done, because it's actually not that great. I've got my deployment YAML here, and now if I got deployment YAML for prod, if I compare those two, well, it's exactly the same except for the namespace difference. So I've just duplicated a bunch of code, right? That's not that great. So if I check the slides again, you know, basically what we've done here is duplicated code, and we need some configuration management for that. So here you can see I've added the prod environment as a separate namespace, and I've just duplicated the manifests. That's not great. So we need something that manages this configuration and that can actually avoid this overhead. So let's get rid of that complete stuff here. Let's just delete the files. There's other ways of doing this. So deployment YAML, I can just get rid of all the YAMLs in here. Ref star dot YAML. Okay, cool. All right, so I have actually a better solution. It's called Kustomize. So Kustomize is a Kubernetes native configuration management solution. And when I say Kubernetes native, what I mean is that it extends the Kubernetes API with custom resource definitions that you can then use to easily interact with Kustomize. Basically, it has controllers running on the cluster. And it does one thing well. So it's really purpose-built to do configuration management. It cleanly separates the static resources. So the deployment YAML and the service YAML that I had, these manifests, they are separated from the specific configuration for those environments. So you have different files called overlays, which are then applied on top of this base static resource. So let's say you have the namespace difference that would only be in the overlay, and you would have base YAMLs, which would be independent of the namespace. An interesting feature there is that it has nifty config map lifecycle management. So if you update the config map, it would also make sure that anything that's depending on that config map will also be updated. It's also part of kubectl. So you can do kubectl-k, and then it will apply the customization files. It is very simple, has a bunch of transformers, so it can still do quite a lot of stuff. It's limited in some way, but still it does pretty well what it's supposed to do. So let's take a look at what that would be with our files here. So we would have, instead of 2 times the duplicated code, we would have now overlays for dev and prod, and we would have base manifests. So those base manifests would be our deployment and service YAML one time, and dev and prod would only have the namespaces in it. So let's take a look how that could work in our demo. So we have a specific repo for that. It's called Go Sample or Go Demo App Ops, where all our ops files are inside there. And let's go into the ops folder and do a tree. So here you can see that you have the base YAMLs and the overlay YAMLs, right? So the base YAMLs are just without the namespace, pretty straightforward. Let's take a look at the overlays. So I can go into overlays dev and take a look here. I have the shortcut for the coloring, so I don't have to write it out completely. Customization YAML. So here you can see that, sure, we have these 2 manifests still mentioned here. That's what we're going to apply the overlay on. So the namespace dev here is going to be added on top of these once we apply that to the cluster. We also specify some stuff about the image tag, and that can also be easily changed if you want to bump the version of your dev environment, for instance. So this is pretty straightforward. Then I think we can already apply this. Let's try it out. Apply here. It shouldn't change much what's running on our cluster right now, because actually it's doing the same thing as what I've just demonstrated before. All right. I think yeah, okay, of course. So this thing here, it means that you first have to build it first, and then you have to apply it. So if I use Kustomize builds, and I need to set the load restrictor as well. As you can see, my overlays are not in, or my base YAMLs are not in the same folder as the overlay. That's just by design. That then you need to, have the load restrictor set to none, that you allow that functionality. There we go. And I want to build this, see what that does. So here you can see that now I've just squashed the overlay on top of that, those base YAML manifests. So we have the same deployment, we have the same service here, and the only difference now is that indeed the namespace has been applied. Right. So we can now apply this if we are, of course, in the right. Switch over to dev. Okay, there we go. So I will apply this kubectl apply -f. There you go. So now it's been deployed. I can do the same thing for prod, which I simply go into the previous folder and go to prod. Here I have a couple extra manifests. Let's take a look at the customization here as well. So again, the namespace is being set. I also have a name prefix here. So what's interesting about this is that I'd like to have a name prefix with, for instance, prod here to indicate that I'm working on prod resources, because it happened to me quite a lot before that I was switching contexts and namespaces. I wasn't actually aware that I was working on the production cluster, and I removed some production resources just because they were named just generic, right? This way I can make sure that I will never delete those production resources by mistake. So I'm going to do that, which means that this is going to create a new deployment for me. Then I also have these patches. They're strategic merge patches. Let's take a look at them. So I have the end patch here. As you can see here, it looks like a deployment, but it only specifies what it wants to add on top of the existing deployment. So here I want to add an environment variable. In the other one, I will add some limits for memory, and the other one will be some liveness checks and readiness checks. So I can apply all this together. Oh yeah, also common labels. I'll add some labels to all these different resources that I have on my cluster then, and they'll all be env prod labels. So let's switch over to the prod cluster. Okay, there we go. I can do the same thing here. I can apply it as well, just like that. And now if I get the resources in my cluster, I can see that now I have actually a new deployment that has been added with that prefix. And the old one is still there, of course, so I can delete this now. This one. I don't need this anymore, and I can get rid of the service as well. There we go. Okay, so if I check it again, I can actually see which labels are being used. So the labels here show that, well, yeah, there you go. Labels have been added. I can also get the deployment. I can describe it. Maybe I should describe the pods. That should be enough. Right. And here we can see on the pod that, well, now we have indeed limits set, we have liveness and readiness set, and we have environment variable here that's being set. So this is actually a very easy way of separating what is specific for each environment from your base YAMLs, which don't really have to be changed. So let's take a look at the slides again. Well, you know, if you talk about configuration management, often the first thing that people think about in Kubernetes is Helm. Helm also offers this as a possibility. You can also use Helm for configuration management, but it's actually much more than that. It is the de facto Kubernetes package manager, and it allows you to build charts which will package your image together with your manifests, and will actually have a bundle of all these manifests that you can deploy into a chart museum or a chart registry or a Docker registry with charts support. It has support for parameterizing your manifests, but that kind of looks a bit difficult after a while. So there's Golang templating possible. I can show you a little example here. So this is actually Jenkins as a Helm chart, and this is the deployment YAML. So if it's just placeholders like this, it's fairly all right, I suppose. But once you start adding logic with conditions, then it gets pretty difficult because there's also no indentation here, so you don't really know when something is starting, when it's finishing, and it's very hard to gauge what your original deployment looks like. So this style of configuration management is a bit more difficult, I suppose. It's also a steeper learning curve. So yes, you can use Helm for this, but actually what Helm really is good in is in shipping off-the-shelf products. So infrastructure components that you can then simply Helm install. So that's fairly straightforward. But for applications that continuously deliver code, it gets harder to use Helm. Also, you have Helm chart version and your image version, which aren't necessarily the same, especially because Helm imposes semver, and semantic versioning is not always the best solution for continuous deployments. So yeah, there are some drawbacks there, of course. So that's why we choose for Kustomize in our demo. It keeps it simple and focused. All right. So that was actually the story. We actually made sure that our configuration is now nicely separated for each environment. Let's hand it back over to Cora.
I think, so just to share my screen. Share. Thank you, Andreas. Cool. So this is shaping up. So here we are. We've got our manifests, and so now we can manage them in a way that won't get overwhelming over time. So basically, what these manifests do is that they declare what we want to be running in Kubernetes, right? This is a declaration, the declarative description of the state that we desire. Oops. Yeah. So the next topic, that brings us to the concept of GitOps, the practice of GitOps. And so this particular definition of GitOps is taken from the Weaveworks website, and they define 4 principles of GitOps. And so the first one is that the entire system is described declaratively, right? So we've already seen the value of this declarative approach of make this thing so, and relying on a system like Kubernetes to make it happen. The other side of this is also important, that the entire system is declared, right? If you only have a declarative description of half of your system, it doesn't really do you much good to deploy half of that because you're missing other stuff, right? So you want to describe everything that you need declaratively. And just to recap, right, imperative, declarative, what does that really mean? So here's an analogy in terms of, I want to get to the library. So I could either tell you, start here and then turn right and then turn left, go to the light, etc. Give you all the instructions. And that implies that I have all the intelligence, I'm the instructor, and you just have to follow those instructions. And you have to start at that starting point, right? If you somehow hit a detour or there's an accident or whatever, the instructions don't really allow you, don't give you enough information to recover from that kind of deviation. Whereas in a declarative approach, I'm just stating a fact, like this is the address, And so, for example, with a GPS, right, you give the GPS an address, and you're yielding to the GPS you're accepting its intelligence and figuring out how to get you there. And if there is a detour, the GPS will correct it and reroute you. So we want for a deployment environment, for a running system, we want to simply declare where we want to be and have the system, aka Kubernetes, do it for us, right? So imperative would be kubectl create, run, expose, edit something, as it's running, etc. And imperative is great for a lot of use cases. This isn't, that one replaces the other. It's just that each has its place and its purpose and its benefits. But for describing a running state, we want to use a declarative approach. So the second principle of GitOps is the canonical desired system state is versioned in Git. And as I said earlier, the GitOps is part of the title, and I don't know the future, so I don't know if eventually there'll be other ways to manage your YAML files, your declared state. But for the moment, Git is so well suited for this that it's in the name of GitOps, right? So Git gives us security guarantees. It gives us an ability to revert back to a previous commit. It gives us versioning. It gives us auditing. It gives us an ability to notify and trigger upon changes. So this is part of sort of the foundations of it. Now, generally, the better practice is to keep your code separate from your declared state. And again, I don't know the future, but right now, tools that trigger from Git commits generally are on different life cycles, right? You have many commits for code versus it's a one to many, right? One commit for a release for many commits for code. So you don't necessarily want to trigger stuff that it has to do with a release lifecycle on every code commit lifecycle. It also gives you a separation of access, right? So the tool that's reading from your YAML updates has access to deploy to production. So it gives you a way to have a clean separation of access. Your auditing logs are better, and it also gives you these, by having Git as the sort of the persistent store in between things, it serves as an artifact, right? And artifacts are always good handoff points. So if you think about setting up a pipelining system, maybe using different tools for different things, they give you these sort of natural elbow joints so that you can modularize, expand, retract, etc. your workflow system as a whole. And so this is the better practice today. This is a cleaner practice today. The third principle here is that approved changes, so changes that make it into a particular branch, let's say of your GitOps repo, can be automatically applied to the system. So of course, Kubernetes we've been doing everything manually, right? And so we've had a person do a kubectl apply of a manifest file. And so it's actually foundational to the idea of GitOps that this be automated, or that they can be automatically applied to the system, right? And for that, we need a tool that's sort of outside of Kubernetes, between Git and between our system of record and our runtime system, something that can actually continuously do that application when there's a change. And the last one is a little bit more novel, which is the idea that now that we have this declared state, and that we have a tool that's responsible for applying it to the cluster, we can also leverage that tool to check for divergence. So if ever your running system becomes different from the declared state, what to do, right? So this can happen, for example, if let's say you add some components, or you rename some components, and you don't explicitly delete the ones that have the old names, then at what point, who decides whether or not the old ones can be deleted? Or if by accident something gets deleted from Kubernetes above a level that Kubernetes can heal, right? A Kubernetes deployment, for example, if a pod disappears, a Kubernetes deployment will replace it. But what if somebody says delete the deployment? Kubernetes is not smart enough to decide whether or not it should replace that deployment, right? That's a higher level in Kubernetes. So Kubernetes will not replace that deployment. So what tool will be responsible for deciding whether or not to reapply that deployment? Or it could be just sort of malicious use cases, or or emergency situations, right? Ideally, you would never go straight to your production system, but there are, it's the real world. So there might be cases where you actually do have to go to your production system and make a change, and then it's not reflected in your declarative state. So what do you do in that case? Do you put it in your declarative state, or do you make your runtime system match the declared state again? So these are decisions, and therefore it's really up to you to configure the system that you're using to behave as you wish. But in general, the entire system described declarative. So that's something that Kubernetes lends itself really well to, accepting a declarative declaration of state and making it true. The canonical desired system in Git, of course, we're using a Git system for that. And in this particular demo, we've chosen ArgoCD as the tool to accomplish principles 3 and 4. There's other choices. Weaveworks, in fact, has WeFlux. But these tools are focused on satisfying these additional principles of GitOps. So we have our desired state. We have Kubernetes that's going to make it so, and we have Argo that's going to hand that desired state to Kubernetes. So Argo is going to do the kubectl apply. That's principle number 3. And it's also going to do principle 4 and make sure that that's true over time. And this is where the concept of the continuous operations comes from. This term continuous operations is that it doesn't end with deployment, but you actually want a tool that continuously makes sure that what's running matches what is declared and what to do in those cases. So let's talk about Argo. So I'm going to switch over to the ArgoCD namespace here. And so Argo, again, like the other tools we've been looking at, is Kubernetes native, so it extends the API with some CRDs. And Argo is one of those tools that's really purpose-built to be good at something very specific. So it just gives us actually two concepts, 2 primitives to work with: applications and application projects. So we're going to be working with the application primitive in this particular demonstration. So I want to define an application for Argo. So I'm going to do that declaratively. I'll show you the YAML for that. So this is from the Argo namespace, a type of application. I give it my name, and I'm saying that I want Argo to go to this repo, which is not where my source code is, right? It's my ops repo. So this is only where my YAML files are. And I wanted to go to this subdirectory, which is the dev overlays, right? Recall from the demo that Andreas just did that you have ops, overlays, dev, and prod. So it's going to get the stuff in the dev directory, which is just that customization.yaml file, right? But Argo supports using Kustomize. And so at the end of this, we will have the overlay applied to the base based on the information in the customization.yaml file inside of the dev folder. And we want it to grab that YAML and deploy it to a namespace called dev. And so I could just apply that, but I'm just going to switch over before I do that and show you the Argo UI. So right now there's no applications defined here. So I could just hit the new app button and kind of provide the same information through this form, right? The path, the URL, give it a name, etc. I could also copy and paste my YAML if I want to put it here. It gives me the sort of scaffolding of that application file. But why not handle if we understand the benefits of having declarative state stored in some Git? I can also store the state of my ArgoCD definitions in Git. So I would rather have this file so that if I have to reinstall Argo, it's easy for me to restate that, right? So reinstate that. So so the first case is the deployment, right? So as soon as I create this application, Argo is going to go to this URL and it's going to deploy my application to development. So let's apply that. And this is what's called syncing. It's syncing the desired state, the declared state, into the cluster. So there we go. It's already there, and there it is. So it's applied the YAMLs. Kubernetes has created these resources, and Argo is reporting on the health. So the green hearts means that the pods are healthy, the service is healthy, and the green check marks mean that the state in the runtime system is the same as my declared state in my YAML files. There's also there's a CLI that you can use as well, right? So you don't have to use the UI. So then what happens after day 1? What happens if the system diverges? So one example is if I go into my overlays and I want to make a change to my YAML, right? So this is a push situation. I can use Kustomize to say the same thing that Andreas did by adding a prefix to all of the prod resources. I want to add a prefix to all of my dev resources. So I want it to be dev, go sample, app for the pod, dev service, etc. So I add that to my YAML. And of course, I have to check it into Git so that Argo will see it. But as soon as I push that into Git, Argo should pull it. There's the, oh, I didn't sign in from that. I didn't sign up. Anyway, so I'm just going to use UI. So you can see that the new resources, so it's added this prefix, dev go, and go, and so these are the old ones, the go demo, and here's the new one, right? It added the prefix. So now the old one is still a healthy pod. It's a healthy service, a healthy pod, but it's also telling me that they're out of sync, that the resources don't match what's in my YAML file anymore. So let me actually, let me skip this one. Okay. I forgot to log in and I have to go get the password. So, so the next decision is what to do. What, if this is different, do we tell Argo to just simply delete stuff, or do we have it send an alert? So right now it's configured, by default, Argo is configured to not take action, but simply notify us, right? So through this, through these alertings, it's just telling us that something is different. So it's up to us to do something. So in this case, I'm going to sync this, and in syncing it, I'm going to choose the option to prune, which means delete the stuff that's in the cluster that's not in the YAML. So I'm going to go ahead and do that, and then Argo is going ahead and deleting those resources from the cluster. So it's corrected that. So I could have set it up to do that automatically, but as I said, by default, that's disabled as a safety measure. Now, there's one other case. So let's do the same. I'm going to deploy the same Argo definition that we did above. We're going to deploy a YAML that defines the production application. So it's just pointing to the production overlay folder and to the production namespace instead of the development one. So I can go back to my applications, and there it is already. So now Argo has told Kubernetes, here's the YAML, and Kubernetes has deployed the production application. And so all is good, all is healthy and green. Oh, you know what? I have to log in. So give me a second. I have to get I'm going to have to get the password. So ArgoCD, the default password is the Argo server name. And Argo login. -u is admin. Password. And I have to, sorry, I had this all sort of pre-scripted to show you with
ArgoCD.
Oh, it's ArgoCD.
Yeah.
Yeah, so I put a lot of time into writing a script that would script it for me. And so I didn't remember the commands. Okay, so ArgoCD, we're going to say localhost, and it's at 9090. Okay, we got it. Okay, so the default admin username and the default password is this.
Password with 2 S's. Almost there.
Did I do that? Oh, shit. Okay. Sorry, didn't mean to curse on camera. All right. All righty. Okay, so now that we're in, thank you so much. Okay, so now we're going to ArgoCD. We just deployed our application, so which was our prod go demo app application, and we're going to set it to self-heal. So by this command, we're basically reconfiguring Argo to give it the authority to just go ahead and reapply the YAML when there is a divergence. So we're really trusting that our YAML, we want our YAML to be what's there despite divergences. So at this point, I'm going to go ahead and delete the production deployment. So this is something that, let's say a malicious user might do this, or this might be just user error, but this is something that kdelete deploy is telling Kubernetes, I don't want this deployment. So this is a situation that Kubernetes by itself is not going to recover from. But if I do this through Argo and I have the self-healing, I mean, it's so fast. You can already see that it deleted it and it's immediately recreating it. So it's incredibly quick. And here it's regressing and fixing itself. And now that I'm logged in, I could actually show you that app list. Right, so you can also use the CLI. You can see if it's healthy, if it's synced, etc. And very quickly, ArgoCD recovers from that situation. So that is this concept of continuous operations. That is an extension that is now possible thanks to all of these, the sort of more modernist technologies. So just to recap, right? So ArgoCD gives us these CRDs, these primitives of an application project, really well tuned for enterprise application deployments at scale, with authentication capabilities and other features. There's other choices. And then WeFlux is interesting. WeFlux, so we've been working, Argo basically takes the YAML and applies it. WeFlux goes one step left of that process and actually notices changes in the image. And what's interesting about that is that both of these projects are actually collaborating and kicking off a Cloud Native Foundation project that is taking the bits that are common in terms of what they do into a common GitOps engine. And I think maybe eventually providing a single user experience from it. But it's really great to see some of the collaboration and the evolution in the ecosystem around this. I think it's really exciting. So that brings us back to here. So we've got our desired state and we've got a mechanism to assure that desired state is true. So this is really the culmination of GitOps, all of those things together. Now, there's a tool that, picking up on where we left off earlier in terms of cloud native build packs, right? What we use to generate the image instead of Dockerfile. We had used Pack earlier, and I mentioned that there's an ecosystem around that. So there's other tools. So what's interesting is that there's one particular tool called Kpack that operates as a service that can also do some things in an automated or autonomous fashion. And so I like to think of that as sort of continuous operations on the health of your images, right? So we saw Pack sort of imperatively rebasing a single application image. But if you have hundreds or thousands of these images on your registry, it would be hard to go through each of them and issue a Pack command, or you'd have to script it or whatever. So the Kpack is a tool that is custom built for addressing that kind of situation. And so I'm going to take a short break because we've been going for a long time. And when we come back, I'll demo Kpack for you.
All right. Yes, everyone, we are going to take a 5-minute break, very sharp, very exact 5-minute break. But like Cora said, when we come back, we've got lots more great information from Cora and Andreas. So everyone, see you back in 5 minutes. All right, we are back. Thank you all for, whoa, hey, I should have had some water during the break. Thank you all for your attention, and I hope everyone is learning great amounts of wonderful things from Cora and Andreas. We are going to jump right back into it because we have so much more amazing information to pass on. So, Cora, I believe it is off to you.
Yes, thank you. Awesome. Am I sharing my screen?
Now,
Am I sharing? I'm not
almost.
sharing. I'm not sharing.
Nope.
Okay. Almost there. Almost perfect.
And there.
Okay.
Yes.
Okay. Starting from the top. Okie dokes. All right. So we were here applying this concept of continuous operations, at least that's the way I like to think about it, to this idea of constantly maintaining that our images are healthy. So we've got automated image management. So just bringing us back to the whole cloud native build packs ecosystem. We saw before we were using Pack as our tool, and we were using the Paketo implementation of the build packs. And the components of that is, of course, our builder image with the life cycle and all the build packs. The platform is orchestrating that life cycle, and this all produces a run image. Now, the ecosystem is broader. It's somewhat new, but it's growing. Of course, the Heroku build packs, right, from Heroku and Cloud Foundry slash Paketo. Those were the originators. Google has recently released one. VMware Tanzu is a commercial superset of Paketo. And on the platform side, we've got you have Spring Boot 2.3.0, which is the latest release of Spring Boot, introduced support for this system through the Maven and Gradle plugins. So now you can actually do a Maven if you just configure it in your POM file to do it during the Maven package by default, or the Gradle build by default. A Maven package could get you an image that uses the same Paketo build packs by default, again, all configurable, in the background to produce an OCI image. And Tekton, you'll see that briefly. We won't demo Tekton using cloud native build packs, but the platform that Andreas is going to demo next also serves as a platform for this directly if you would like. Anyway, the one I'm going to highlight is KPack. KPack operates as a service. So you install it into your Kubernetes cluster. And again, same as all of the other Kubernetes native systems that we've been looking at, it provides custom resource definitions so that we can just use YAML to create the resources that we need to get KPack to do what we want it to do. If you're familiar with Cloud Foundry or Heroku, you're familiar with this idea of a hosted build pack system where you just push your code and the system takes that and adds the necessary runtime bits and makes a runtime, containerizes that and runs it on the system. So KPack gives you part of that experience in terms of being a hosted system. It just spits out an OCI. It doesn't actually deploy it to Kubernetes, right? We still need Argo to do that part. But it will automate, it does both. So when we were looking at Pack earlier, we did a Pack build and we also did a Pack rebase. KPack will do both of those operations. And it'll do a build automatically if you point it to your Git repo, or if you point it to a builder, right? The builder being the build packs, but also the run image that you're actually going to use at runtime. It'll look at all of those three, and it'll, at any point if one of those three changes, KPack will react and change your image. So if the builders change, if the build packs change, or if the source code changes, it'll do a rebuild. And if only the run image has changed, then it'll do a rebase on the registry. So it's really great. It's a very powerful security tool if you look at it from the perspective of being able to update the operating system on all of your images within a few seconds. And just to recap what that operation actually looks like. So if you have a run image that's got a CVE in it, a new run image, this is the OS patch is made available by a new run image. So when you execute that, the platform issues a rebase. What it's really doing is it's going to the registry and it's updating the manifest, that is the definition of that image, and it's changing the pointers that are pointing to the run image layers to the new ones that have changed. And that's why it's so quick and powerful, and it's happening right on the registry, and there's no rebuild installed, no rebuild involved. So I'm going to demo KPack for you. So we've got KPack is installed in a namespace called KPack. That's the actual installation, but I'm just going to create the objects that I'm using for this demo in the default namespace. So again, we can look at the custom resource definitions that are installed by KPAC. So it has concepts of builder, which we've seen when we did a pack set default builder. This would be one way to say, I want to use this builder, right? Whether it's Paketo or Heroku or Google or Tanzu, you would say that in your builder. There's also an image, and so this is the main resource where you say, here's my source code at this URL, or maybe my jar file is at this URL. My registry address is here. This is the destination where I want to publish the image. And this is the builder, so you would have a reference to this builder that you created inside of this image. Those are the two top level items, resources. The image itself creates builds for every build, and it uses pods for the execution, and it uses the source resolver to actually pull and check for changes. And the cluster builder is just a variation on the builder. One has access to all namespaces, and one is namespaced. So for this, I'm just going to show you a definition of an image and a builder first. Oh, before that, let me show you actually, there's some experimental ones in the background. So when you do a builder, it has, as we said, the builder is composed of a build image, the image on which the build is going to take place, all of the build packs that could potentially participate in building your application, and also the run image, right? So there's some extensions, some experimental resources that break that down into the subcomponent pieces. And so I'm actually going to be using these as well to be able to control a rebase operation, because otherwise I can't control the release, right, of a new, as we said, the same way we had to do it with pack, right? We have to have an ability to specify a different run image outside of the builder. So we're going to break it down. But before we do that, I just want to show you the simple setup using the defaults. So here's the definition of a builder. So I'm simply saying, I'm giving it a name, and I'm just saying, use the same Paketo build packs that I've been using so far. So that's straightforward. And then for my image, I'm saying, here's my, first of all, use that builder. And then I'm giving it access, write access to the Docker registry that I'm writing the image to. So that references a credential, of course. Here is the source code. So in this case, I'm looking at the code, right? Argo is looking at the YAML files. KPAC is looking at the code. KPAC is going to produce an image based on the code. I can have a branch here, like I could put master here. And if it's master, then KPAC, every time that there's a commit to that branch, then KPAC will kick off a build. If it's a specific SHA, a specific git commit SHA, then KPAC will just build that thing once, and that's it. And so right now we have it configured this way. And again, we're publishing to Andreas's account on GitHub. So this is the destination. And KPAC has an auto generation strategy that you can disable it, but it has an auto generation strategy for the tags, so it'll apply that automatically. But rather than actually set that up, let's look at the piecemeal setup using those experimental extensions. So I'm going to show you, this is all one file. CB.YAML is the same one, but it has 3 documents in it. I just put them all into one file for convenience. But the first one is goes down to here. Okay, so basically here I'm saying one of the things that we need to make our own builder is we need build packs. And I know that the builder that is the Paketo build packs builder has build packs inside of it. So I'm just going to use those. So I'm going to say, get the build packs from this image. Don't use this image as a builder in and of itself, but get the build packs from that image. So that's step 1. I'm also going to need a base image and a run image. So here I'm saying that's what's my stack. I'm using this is the ID of my stack. And I'm also just going to reference the build image. So the top one is builder, right? This is the actual build image on which, the base image on which, that is the base of where the build happens, and the run image. So I'm using versions 19. I'm pinning those versions right now. And then the last one is put those together into this thing called a custom builder. So I'm referencing the stack, I'm referencing the store, and I'm again giving it access to Docker Hub, because this is actually going to produce a builder for me. And then I'm giving it a little bit of extra information. The build packs that are getting it, I'm saying, in what order do I want to apply them to my application? Well, I know my application is Go, so I might as well put that one at the top so it's faster, right? If I put it at the bottom, it's going to check all these others first. So once I do that, I can apply that to Kubernetes. And it's going to go in the background and create this new image for my custom builder. And at a certain point, if I do this, it's not ready yet, so we'll just give it a second. Let's see. Is it ready? Okay, now it's ready. Okay, perfect. So in fact, I can go to Docker Hub, go to the main account, and there's my builder, right? Updated a few seconds ago. So I literally just created a builder, super easy. So now that I have a builder, I can create my images. And just to show you this with a little bit of scale, we're going to do this 3 times. Or I'll show you once, but it's done 3 times. So I'm going to create an image, and I'm still, same source code. There's no reason to change source codes. I'm just going to publish. I'm going to build the same source code 3 times, but I'm going to give it a different name as if it was a different application. And I'm building from master. And so this particular one is going to be called demo image 1. It's using the custom builder that we just created, and it's going to create an image called demo image 1. So I have 2 other files, demo image 2 and demo image 3, right? So let's apply all 3 of those. Okay, so KPAC is getting this information for the first time. And so it's basically going to do a build using the 00.19 versions of the build and run images that we've declared. So I can see what's happening in the background. As we said, the image creates a build for every build that it does. So here I have a build resource for each one of these. I can also get information about these builds. So let's pick this one. And just, information about what's happening, including, for example, this is cool, is giving me the reason that KPAC was kicked off. So in this case, if it's a change to the application source code repo, if it's a Git commit coming from that repo, it says it's a config. So there's that. There's also, I'm going to show you in a different window, I can also do the logs. So the way that this works is that in the background, there's a pod that's starting that does every step in the life cycle. Remember the steps that we saw, that was analyze, prepare, detect which build packs, apply, do the caching, apply each build pack, and then export. All of those steps are happening in a pod, but each one is a separate, what's called an init container. So if you just do the kubectl logs on the pod, it doesn't actually stream you the logs from each individual init container. You can write a little more complex command to do it with kubectl. It's not that hard, but KPAC, recognizing that, provides this separate CLI that does it for you. So all you have to say is the name of the image in the build. You don't even have to know the actual UUID on it. And so here we see. So so the prepare is happening in one init container, the detect in another, the analyze, the build, and so on. And so it's done. So I can also go to here, to Docker Hub, and confirm that, in fact, KPAC has published my 3 images. So image 1, image 2, image 3, right? So now that's a build. Now I want to do demo KPAC. Now I want to do a rebase. So for that, I want to update, the only piece of information that I want to update in order to make sure that a rebase is triggered is the version of the run image. And so I'm changing from 19 to 20. And then I'm just going to reapply that YAML file. And you can see everything else is unchanged, just the stack is reconfigured with a new run image. And I can see the builds. And right away, there's a build number 2 for each one of the 3 applications. And I can also see, let's pick this one, let's say this one. Just describe the build, and what I want to show you here is the reason that it reports. So here the reason is stack. So I know this is one piece of information that tells me it's a rebase and not a rebuild. But I can also come here and say, if I look at build number 2, the log actually is different, right? It's a very short log, and it doesn't have all those. It doesn't have all the other phases. It just says rebase. And if I come up here, I can refresh this. And updated a few seconds ago. So it's automatically gone through all of the images and updated the operating system. So that's the most amazing patching of a situation like Heartbleed or Spectre that I have ever seen. And of course, then the images have to be reapplied to the cluster. But that's it. So it's really powerful. And I think that's all I have to show you here. Okay, so let's go back to the slides. And that's it actually. I'm going to hand it back to Andreas.
Awesome, thanks.
Yeah.
All right. So yeah, thanks for that, Cora. So we've got our image, of course, our image resource now for KPAC that can either be looking at master branch or another branch and just make a build, make an image for each of the revisions that we have, or we can pass in a specific revision into that KPAC image, and that will then trigger an image build by KPAC. Now, of course, we don't want to have an image created for builds that aren't, for code that isn't actually working, right? So code that hasn't been tested, we don't really need an image for that. So it would be nice if we could just have some pipeline that could test our code first, lint our code, and if that's successful, if it's a validated commit, then only build an image. So we will need some kind of workflow automation for that. So that could either build or test or lint our code, and then pass that on to KPAC to build the image, and we publish that to, for instance, a GitHub. So that's something that we can look into. But then once the image is in our image repository or registry, it still needs to be deployed. It doesn't get automatically deployed because the dev overlay or the prod overlay, it mentions a specific tag. So we also need to update that tag. You need to say that the image that we've just built, take that image, the digest or the tag, and apply that to the cluster. So we're also going to need something on this end, and we can also build a pipeline for that. So this is where workflow engines come into play. And workflow automation has been around for centuries, I suppose, or at least a while. And as you can see, you have Jenkins, you have Concourse, CircleCI, Spinnaker, GitLab CI, Travis. They all have a similar approach to workflow engines, but they have slight differences in terminology, in primitives that they apply. Jenkins, for instance, has pipelines and stages and steps, whilst, for instance, Travis has stages and jobs. So they all have their own nomenclature, and basically Tekton, which is another tool that is Kubernetes native, aims to kind of standardize that, at least for Kubernetes. So let's take a look. There we have pipeline, tasks, and steps. Tekton itself is Kubernetes workflow engine, Kubernetes native and workflow engine, so it cannot run anywhere else than on Kubernetes. And it will use CRDs to help you build out your pipeline. So it tries to standardize your pipelines, and it can be used for other stuff, but it's particularly well suited for CD. So the internals of the Tekton pipeline look like this. So I've already mentioned it's pipelines, tasks, and steps, but there's also other stuff. So if you look on the left side, there's an event listener. Event listeners are basically just receiving events from, for instance, webhooks that you could send it. So if you have a GitHub repository or even a Docker Hub registry account, you could send event hooks or send events through event hooks to the event listener, who will pick that up. Then it will use a trigger binding to look into that event and filter out information that it needs for the pipeline. So mostly it looks at the JSON and takes out certain fields, then fills that into the trigger templates, which is basically a template for a pipeline run. So imagine you have a pipeline of different tasks to execute. A trigger template will define how you actually execute that with the data that you receive from the event. So as you can see here, we have a pipeline specification on the top and pipeline runs at the bottom. And pipeline runs are the instantiation of those pipelines on the top, and task runs are instantiations of tasks. And every task has a number of steps, and every step is basically a container. So this is very flexible because you could do anything in such a container. You can run any task that you'd like, any action that you want to perform. And on the right-hand side, you can see there's a catalog here. So tasks can be part of a catalog. And I can show that as well on Tekton CD, the repository catalog. there are already a bunch of different tasks available that you can choose from. You can reuse these and combine them together as you wish. We will use, for instance, the Golang tasks right here, Golang. So we'll use the lint and the tests. And if we take a look at how that actually works internally, it just executes code tests on a workspace that we define, which will have our Git repository inside. It will execute that test, and it will use certain parameters for that, which then eventually get filled in by the events that is coming in via our event listener. So this is the basic setup. It's not that difficult, but of course, there's a lot of YAML involved. You can of course create tasks and then store them in your own catalog for other teams to reuse. So that's a powerful model. Right. So if we take a closer look into what our Tekton pipeline will look like, this looks a bit overwhelming, but actually it's just the same as before. You have an event listener, you have the trigger template and the trigger binding, and then pipeline runs with a number of task runs. And these task runs, they just clone the repository, they lint the code, they test the code, then they clone the GitOps repo where our image YAML is inside. So if you remember Kpack having that image, this image is stored in our GitOps repo. So we will update that image with a new SHA from the validated commit that we just built in Tekton. So just imagine you make a code change that will then trigger a webhook. It will go into this build pipeline, which will lint and test the code. If it's successful, it will take that SHA and it will update the image for Kpack with that SHA so that Kpack can then automatically update, create an image and publish it to Docker Hub. That's basically how it works for us in our pipeline. And okay, of course, if you just put it in here in the ops repo, it will not automatically be picked up by Kpack because it's a specific commit that we're going to be looking for. So we're going to update that manifest, that Kpack manifests, the image, and ArgoCD will, in our case, pick that up. We will scan for it, and it will automatically be applied on the cluster through ArgoCD syncing. So this is basically how we set this thing up, and it's nice that we can use ArgoCD here as well. So normally ArgoCD is what you think of a CD tool, so continuous deployment of your application, but you can also use it as part of your CI orchestration. So here we are actually continuously delivering or continuously deploying at least the Kpack image as well to make it build new images. So an interesting approach, I would say. And then if we look further to the right side, so Kpack pushes something into Docker Hub. There's a new image available. We also want to automatically update our manifests, our dev and ops dev and prod manifests to reflect the new image and automatically deploy that into the environment. And there we'll also use Argo, of course, and for the pipeline we use Tekton. So this is the setup. So let's take a look at the demo here. So here we go. So I have a specific folder for that, CI/CD Tekton. There's a bunch of stuff in here. So if I check all the contents, there's a lot of different YAMLs. So if you like writing YAMLs, you're going to love Tekton because there's a lot of different YAMLs to write. All these different blocks that you saw on the slide, they have their own YAML to write, their own manifest. Of course, everything is well knitted together, but you have to write that yourself. So let's take a look at our pipeline, the build pipeline to start from. So the build pipeline here, it's basically defining a couple of parameters and some workspaces. These workspaces will contain the Git repositories. We fetch the repository, so we do a git clone. This is a task that is also coming from the Tekton catalog. We then will use that cloned repository to lint. And here you can see that this is configured to run after fetch repository. But the test is also configured to run after fetch repository. So those two tasks will run in parallel. Then once that's tested and linted, we fetch the ops repository to let Kpack know that Kpack can build a new image. So we update that specific ops repository. And in this task here, update image revision, we're going to set that specific revision in that image manifest. So that's how this works. So if you check the slides again, we are now here. So we've updated the GitOps repo, and now Argo will be able to pick it up and apply it to Kpack. So let's see how that works. So Argo. So here we have Argo deploy image. So we can also take a look there. So this is similar to what you've seen before with Argo, but now we're pointing it specifically to this folder here that we have actually here, image, which contains our image. Right, so it's going to monitor for changes on this image, and if there's a new image, it will automatically deploy this. Right, so let's go back to Tekton. Okay, so on the slide deck here, once it's in KPAC, it will automatically push something to Docker Hub, which we'll see. And then we need to build this pipeline here, which looks at Docker Hub from another event listener. It's going to take that information and it's going to update the ops repo with the dev overlay update. So we can also see that here in this pipeline. So let's take a closer look. So here we're going to fetch a repository again, and we're going to update the repository in this task. It's a custom task that we've created. So we can also take a look at this one. Which one do we have here? Ops dev task. All right. So what's going on in this task here? This is not one that is coming from the Tekton catalog. This one's something that we created ourselves. So what we're doing here is we are changing the customization YAML in the overlay dev folder, and we're setting the tag here specifically. Normally, it would be best practice to set the digest of the Docker image, not the tag, because the tag is actually a floating target. It doesn't really pinpoint a specific artifact. You can override the tag with another image, of course. So if you use a digest, then you're certain that you're always going to deploy the same thing. Then we're going to make that change and commit it to the repository. Okay, so I think we're ready to apply everything. So let's go back to Argo and apply this. So, okay, apply. There we go. There we go, okay. And then in Tekton, now we can apply all of this. And there's a bunch of other stuff that gets applied now. So of course, we've got the event listeners, we've got the trigger bindings, the trigger templates, we've got a number of persistent volume claims. So all of this stuff is scaffolding, is foundation for being able to run our pipeline. Right? So now, if we go into the other folder, so let's go to workspace, to our main application, code demo app, right? Right. So here. Okay, so now I'm going to make a change to let's see, because the webhooks didn't work, so maybe I should use this instead. Yeah, okay, this is fine. So let's make a change in the hello server, a Go file here. Let's change world to hello spring1 tour. There we go. Okay, let's save that. And okay, let's commit this to Git as well. Okay, tour. There we go. Okay, so this should have triggered, if I push this, another pipeline run. So let's take a look. So we have this command line to tkn, Tekton, and I can run PR list here to get pipeline runs. Let's take a look at the logs of this pipeline run. All right, so as you can see, it has started the fetch repository task. So this is cloning my my application, and then it will, with that information, it will then be able to run the list, the lint, and the test. And here you can see it's running in parallel. So linting and unit testing. As you can see, lint and unit test. There we go. And then the next step should be that it's going to update the image. Okay, so we have to clone the ops repository for that because the image is in there. The image manifest for KPAC, of course. There we go, revision master, it's fine. And then here, if I scroll up a bit, it has updated the revision to our specific commit here. So the commit here is 9f, cd, whatever. And so it's going to put that in that folder in that specific image YAML file that was used for KPAC. So that's in there, and now it's committing that stuff. And we should be ready now to do a build, a KPAC build. Let's check Argo if that image has been picked up. Well, let's first see in the repository, of course, yes, it's there. Awesome, the revision has been updated in image YAML. And now in Argo, if we just refresh our page here, yes, it has actually been synced up. So Argo has now notified KPAC that there's a new image to be built. So let's check the builds here. Default namespace. There we go. A new one has triggered. So let's take a look at the logs here of Go demo. Okay, let's just check it out. There we go, number 11. All right, so that's the right commit hash shot. That's good. All right, so it's doing the same stuff that Cora has been doing. All right. All right, the image is there. This is a new tag, B11. So let's take a look in Docker Hub, and if you refresh the page, B11, oh, the latest. B11 is there. Great. So let's check the new pipelines. Okay, the second pipeline has now triggered based on that webhook on the event listener. Okay, let's take a look at the logs again. So it's going to clone the repository again. Now it's going to be the ops repository because we want to update the overlay, dev overlay, right? We want to automatically change the image tag in that overlay. Right, let's take a look at the scribe. So as you can see here, B11 was actually used here for this specific build. Okay, let's go back to the logs. It's the right commit hash, the end of, actually the head of this repo. Okay, so we have made a change here. The customization has been changed, and now it's going to commit that code to the ops repository. And changing that, committing it, and pushing it. A second. Yeah, there were some problems with GitOps today, so basically it's always a bit funky. Okay, B10 is here, so if we refresh, okay, not yet. There we go. Updating the SHA. And we should be there momentarily. Okay, it's pushing now. And okay, not yet. It's taking a while to do this push apparently, so there we go. There it is, B11. So now if we go back to Argo, we should be seeing on our dev application an update coming in. So if we refresh the page, it has been syncing, yes, and it's already deployed, great. And it is green, which means that we should now be able to see our change that we've done at the start of this demo. So if we check specifically namespace dev, and then we kind of port forward this pod. Okay, let's go forwards on port 8080, I think it was. But let's put it on something else because Argo is already on 8080. There we go. Namespace dev. Are we already in there? That's fine. Oh, yeah, I have an alias here, which makes it the port forwarding, but I have to type the alias correctly. Okay, so KPF, that's fine. It's forwarding it now. And now if we make an HTTP call, which is the same as a curl on port 8085, we get hello Spring One Tour. Yes. Okay. So that's the entire pipeline. Cool. So if we go back to here, what we've seen here is basically run this commit through this entire pipeline up until the point when we have a new deployment on dev. So this is, it's quite a big pipeline here, but yeah, of course, Tekton also gives you full flexibility on all these parts. Cool. So we have seen a path to production here, which is only a part of what you eventually would like to build. But there's more to it, right? There's also the point of collaboration that you can look at. You can increase collaboration using pull requests as well. And there's this new thing called GitOps, It's been around for a while because actually, if you think about it, it's a lot like chatbots. For instance, IRC chatbots that, for instance, like Fishbots or other bots that you could put on your channel and that you could actually chat to, and that would do things for you. It would automate certain workflows. So ChatOps is kind of a continuation of that. Another example is this little guy. I don't know if you remember that. One of the worst inventions of all time, according to Time magazine. But also Clippy was able to answer questions that you had on the fly, right? So it was kind of a similar idea. But nowadays, ChatOps is much more advanced, and GitHub has coined the term as a collaboration model that helps to connect people, processes, and tools, and automation into a transparent workflow. And this is then achieved through PRs, pull requests, and certain commands that you can execute. So if you look at Prow, Prow is a tool that is being used on Kubernetes, the Kubernetes repo, and it uses integration with, it kind of makes an integration between the pull request and whatever you want to execute from that pull request. So it's in essence, it's an eventing engine that can receive webhook calls. So it can also trigger Tekton pipelines, the ones that we have as well, and then can report the status back to the PRs. It also supports a wide range of ChatOps commands that we're going to see. It can also be complex to set up. I wouldn't recommend it because it's quite a lot of code that you have to configure. And it only supports GitHub.com. So if you don't work with GitHub.com, it is kind of not really useful for you. So Jenkins X has a fork called Lighthouse, which is far simpler and has less moving parts. And it has support for GitHub Enterprise, GitLab, and Bitbucket Server. But it can do the same thing. It supports the same plugins as Prow, so you can have the same commands, and they work in the same way. So if you want to see Prow at work, you can simply go to the Kubernetes repo here and check out the pull requests. There's one, for instance, here. Let's see one with a couple of comments. Yeah, here, this one should be fine. So here you can see that there's this Kate's bot, the robot. So Kate's CI robot, that actually is Prow at work. So it adds certain things on the ticket, on the PR, like labels, but also it can be interacted with /assign or retest, all that kind of stuff. So that allows you to collaborate much better with pull requests. It also manages the gates of the pull request. So things that, for instance, approvals or certain builds that have to be ran before you can actually merge this code. So all this stuff is Prow. Of course, the builds themselves are other systems, of course. Okay, so this is Prow, very short demo because we're almost out of time. But this leads us into integrated solutions, because if you don't want to set this up yourself, then it might be useful to use something that is already configuring this for you. If you look at our pipeline here, there's a lot of different technologies here, different blocks. They all do one thing well, which is good. But of course, it might be nice if this is scaffolded for you in the first place. Path to production here as well, all these different blocks, if you have to couple them all together, that's not that straightforward. So Jenkins X aims to simplify that. So it uses a lot of the technologies that we've discussed today. So it uses Prow, but also Tekton, and it uses something called Draft. So Draft is like, it's kind of has specs that will bootstrap your application for you. And the bootstrapping will include things like, the application itself. So if you want a Go application, it will generate some Go code for you. Very simple, but okay. It will also generate a Docker file for you that you then have to manage yourself, of course. And it will also put a Helm chart in there. So a lot of things already set up. And if you use Jenkins, you can use a thing called Quick Start, which will generate your pipeline as well for you. It's kind of an opinionated pipeline. Now I say Jenkins, but I should really be saying Jenkins X, because this platform, Jenkins X, has nothing to do with Jenkins. Sure, it's from the same builders, from the same company, but it is not actually related technology-wise. Right? It is a completely separate project. It is also completely tied into Kubernetes, so you cannot deploy it anywhere else than on Kubernetes. So it hides the Tekton's complexity and Prow's complexity and all the other stuff that it integrates with, but it does still provide this flexibility. So let's have a quick look at Jenkins X. We don't have much time left, but I can quickly show you what the result is. So here you can see that this is a cluster. I have a cluster here, JX Absolute Cicada. That's just a cluster that I set up on GKE. And Jenkins was installed on here. And here you can see that Jenkins has this Jenkins requirements, which is actually the declarative configuration for Jenkins X itself. So it does have that all in Git stored, which is pretty nice. Then I also have a number of applications that I want to deploy. And here you can see one of my applications, my 5th repo here that I created. This is actually scaffolded with such a draft pack. So you can see that there's scaffold.yaml itself. There's main.go, there's the chart, and the Docker file. So this stuff is all automatically generated. And an interesting thing is this Jenkins X file. So the pipelines that we see in Tekton, they are very complex. You have a lot of YAML to introduce there, but you have so much flexibility for that. So it really depends on your use case there, what you want to use. But often it's a good idea to look for something that is abstracting that complexity. And here you can see that Jenkins X, basically all it says is, well, we use the build pack Go. Now this is not the build pack Go as in a cloud native build pack, has nothing to do with that. It's the draft pack, but still, it will automatically create for you this pipeline, this Tekton pipeline with all the tasks that you would normally need, right? And you can override them with something like this. So that is pretty powerful, I think. And it's still using underneath all the technology we discussed. So once you have deployed this, it will also put it in its own repos for separate environments. So this is another style of having GitOps repos. Here we have a repo for each environment. And as you can see here, every application, or hold on, it's not here, it's in the environment here. Every application is here mentioned that has to be deployed with a certain Helm chart version. So that is a different approach. And as you can see, the thing I talked about with Helm, the different versions between the Helm chart and the image version, that's, of course, here you just mentioned Helm chart version. And that will then take care of the deployment for you. Then here we see production as well, same thing. And we have pull requests as well here. We have some closed pull requests here. And you can see that this is also managed by Prow with the fork of Prow Lighthouse. I have made my own account user for Prow or for Lighthouse, so it's kind of silly, but okay. As you can see, this looks very similar to what Prow did, right? So on this story here, it was actually the same thing. So with Jenkins X, you get that out of the box. And you can interact with Prow or with Lighthouse by tapping these commands, and that will just do stuff for you, like add a cat picture, right? All right, so that's basically Jenkins X. Okay, cool. Always successful. All right, so one thing I wanted to mention about this flow, as you can see here, we have pull requests with this collaboration model, different handoffs. Maybe that's a bit overkill for your team. If you use pull requests, like Keith says here, it's kind of based on a low trust environment. And with open source technology, open source software, you can't really trust the other person, another person who's not part of your company at the other side of the world, in another time zone. It's difficult to have trust in such an environment. So this model really works well for open source software. But for your own team, it might be difficult. It might be adding complexity on top of your team without actually having a lot of value. So if you pair program, then you don't really need pull requests. They can be still useful, but maybe the whole process might be a bit overkill for you. So Keith also says it here, imposing pull requests on devs in your own team is like making your family go through an airport security checkpoint to enter your own home. So it's maybe a bit too much, right? But you can also, in Jenkins X, turn it off, of course. And Camille also states it nicely, conflating OSS and private software development isn't always a good idea. Often it's a bit bandwagoning. We look at open source software as the example, but it doesn't always match our situation, right, in our own team. Cool. Something to almost close off here, Spinnaker is an interesting tool as well. It's also this integrated solution. And the interesting takeaway of Spinnaker is that it has advanced testing automation. So of course, for instance, a canary deployment is becoming a commodity with Istio. but having automated canary analysis that will validate your baseline with your canary version based on metrics. Now that's the next level, and that's actually the standout feature of Spinnaker. Now Spinnaker gives you support for that. It also has interesting UIs across clouds, clusters, regions, deployment platforms, everything. So that's an interesting platform to look at if you really want to have fast and safe deployments. So if you want to test on production, right, Spinnaker offers you tooling to make sure you can roll out in a strategic way with this automated canary analysis and more. There's also GitLab CI, which also has this feature called Auto DevOps that also gives you this pipeline out of the box without actually having to configure anything, just like what we saw at Jenkins X. Cool, and that leads us to the last point, opinionated pipelines. Actually, I was already talking about that. So if you have pipelines that are coming out of the box, it really helps you to limit complexity and to make sure that you don't have to maintain your pipeline complexity over the years, right? Because actually, if you look at it, at our big graph there of all the different components and part of our pipeline, 80% of the projects kind of have the similar pipelines. Sure, you might have differences here and there, but the gist of it is similar. And it kind of goes back to the idea of convention over configuration, which Spring Boot also does. So Spring Boot also makes sure you don't have to write a boilerplate code for the Spring framework to make it work. Just like Cloud Native build packs, also you don't have to build that Docker file yourself. It does that for you. Spinnaker makes sure that your deployment strategies are automated. So you don't have to write that yourself. Jenkins X as well, and Auto DevOps as well. So these things form a theme, and they all kind of try to make your life easier, not to have to dig into these nitty-gritty details, these nuts and bolts of, for instance, the Tekton manifests. But of course, if you want that flexibility, then that's still fine. So you still have a lot of different options here, and it's up to you to choose whatever fits your team specifically best. And I think that's kind of the wrap for me. That comes back to the path to prod, of course. So every path is specific for each team. But I hope that we've shown you a couple of tools that you can use for each of these steps, and that you can then combine or have an integrated solution if you'd like. So that leads me into homework. Cora, maybe you can talk about this a little bit.
Okay, awesome. I'm just going to do this super quickly, but we prepared. Oh, yeah, if you want to just go to the next slide, Andreas, yeah. Thank you. We prepared a set of Katacoda scenarios that you can go through to set this up yourself with descriptions of what's going on and why and what and where. So they are, oh, the address is not there, but Bob is going to show you the address, I believe,
I think in a second.
Oh, it's on the next slide. Oh, we managed not to put it in there. Oh, there we go. Okay. And the Gitter. And yeah, so if you guys get stuck, so we'd love for you to go through these exercises so you can get a little bit more hands-on. We'll be here tomorrow for the fireside chat. So if you want to bring questions from the talk, as well as from the exercises, you can bring them tomorrow to us. And there's also a Gitter that we created in case you get stuck and want to reach out to us. We'll try to keep an eye on that. That's it. Thanks.
Yes, wonderful. Thank you. I love that there's homework. It feels so official now that it's like, we did this, now you do it. So everyone write that down. Maybe we can tweet it out. We can figure out ways for it to get a little bit more public. But we expect you to do your homework and show up tomorrow with some great questions. Again, we do have a fireside chat tomorrow at 9 a.m. You're going to use the exact same Zoom link that you used to get in today. For tomorrow, and you can add your questions to the Q&A at the bottom there. If we have any that weren't able to be answered today by our panelists, then we'll see if we can add those in. And tomorrow in the fireside chat, we have some really incredible people. Of course, we have the wonderful Cora and Andreas, but we also have the one and only Paul Charkovsky-Golievsky. He's a tech advocate. He's a tech advocate for VMware Tanzu. We're adding Lyle Murphy, who's a product manager for the Tanzu development ecosystem, Mark Fisher, who's a senior staff engineer for Spring, and Mark Pollock, who's another senior staff engineer for Spring. So some really excellent minds to kind of talk about the CI/CD process and the best ways to implement it for you and your enterprise. Let me just make sure. Again, it's katacoda.com spring1-tour-2020-CICD. I hope you wrote that all down right now. But if you haven't written it down, we will again find a way to get that out to you. So come back again tomorrow, exact same Zoom link. Thank you all so much for joining us. It's 9 a.m. Pacific Standard Time. Be there or be a square. All right, my friends. Cora, Andreas, great job. Thank you. Paul, Brandon, Tasha, Yvonne. I know I'm missing one other person there, but everybody, thank you so much. Ben, you've all been incredible, and we really couldn't have done the show without you. So see you all tomorrow. Thanks again.
Thank you.
Bye-bye.
Do we do it every